So then I think it's good too to look at how each of the different species are actually using this freshwater environment that we're all going to go work on today, right? So the anchor, unless I'm mistaken, somebody correct me if I'm wrong, there's no chums in the anchor, right? It's a 4-species river plus steelhead.
There's some that show up, but they're not.
Sure, like a stray or two, yeah. So really, when we're working on this freshwater habitat, our focus is on coho, sockeye, chinook, and steelhead, because they're spending 1 to 3 years in the freshwater, depending on the stock, depending on the individual fish. Pinks and chums hatch, once they're able to swim, they head straight for the ocean, and they're rearing in the estuary, which still very important, but a totally separate topic, right? So coho are spending 1 to 3 years in freshwater, mostly using the slow areas, streams and wetlands. Coho expand everywhere. I found coho where they had to swim underground, underneath the log, to get into a lake that doesn't have surface water running to them. So coho are your exploiters. They're just everywhere. If it has water, they can go in. And the adults are oddly, they spread out more than you think too. I've seen adult coho in places I can't figure out how they got them. Sockeye are really your lake specialists, which is probably why we don't have a lot of sockeye in the Inga River drainage. So the better example would be like up on the Kenai. Ski-Lac Lake is very important. Upper Russian Lakes is very important. On the Kasilof Tustamina. So they're hatching in tributaries to the lakes, and then they're rearing in the lake itself. But still spending 1 to 3 years in freshwater. So that's a pretty important part of their life. And then Chinook. I don't see a lot of these guys in my work because they're mostly in the main stems and then those immediate tributary streams. So out last week I caught a whole bunch of Chinook in Beaver Creek in the lower Kenai. So they're getting into the larger streams. They're running off the main stem, rearing there for just 1 year. And their body shape and their size is more conducive to faster flows than coho. Coho, you'll find them in like scuzzy, stagnant ponds that almost don't have oxygen. That's really what they're designed to exploit. And like I said, the pinks, they're hatching, they're swimming and going straight to the ocean when they're like the size of your pinky nail. It's pretty amazing. So what I kind of decided to do with this is I'm going to go through all the different ways that healthy vegetated stream banks drive salmon production and why they're so important. So it's going to be kind of a piece by piece presentation. And the first one is stream banks and food. Just the way that stream banks provide food for juvenile salmon and other salmon. And I like to break it down in my own head into the simple and the complicated. So the simple way is that healthy vegetated stream banks provide habitat for the organisms that salmon and other resident fish feed on. That's fairly simple. Like, they eat plankton, aquatic insects, terrestrial land insects. And those stream banks are just providing habitat for those things. The complicated side is that certain riparian plant species, so those are the plants along the bank in the wetlands like we talked about, along with chemical processes in riparian soil, generate nutrients which act as the nutrient base for the whole ecosystem. And I'm going to get a little bit more into that in a second. First off, the simple. Vegetated riparian areas provide habitat for terrestrial and aquatic insects. Plankton and insects make up the majority of rearing salmon diet. Keep in mind, a big juvenile coho is only 200 millimeters. So it's not that big. They're not big voracious predators. So they're eating mostly plankton. Like that's a stonefly larvae there, mayfly larvae, mosquito larvae are huge. And there's a really great case study out of Beaver Creek. That's in the lower Kenai. If you've ever driven to Kenai, you've driven over Beaver Creek on the spur there. It's a pretty major tributary. And a grad student did a study out there a couple years ago that showed in early summer, juvenile Chinook and coho ate something like 80% to 90% aquatic organisms. But by late summer, they were eating almost all terrestrial. So they were either getting mosquitoes off of overhanging vegetation, off of alders, maybe jumping in the air and grabbing them. I've seen that too. So the point is that just having good habitat in the water is not enough. You have to have good habitat up on the banks. Because if you think about it, we all hate mosquitoes, but when are you getting bit up the most? When you're down walking in an alder and willow swamp, or when you're standing in a parking lot? Definitely down in the lowlands, right? Where there's not as much wind, lots of shade, lots of water. So you have to keep that habitat up on the bank as a food source for the salmon too. It's kind of weird to think about, but it's true. All right, the complicated side. So riparian plants and bogs provide nutrients to streams, and these communities are the primary producer in many streams where limited nutrient input exists. So the anchor is not necessarily the best example of this. I like to use the Snow River. So that ultimately flows into Kenai Lake or by Seward. kind of by Seward. So there you have a glacially fed system. So glaciers aren't putting out a ton of nutrients on their own, right? It's just a whole bunch of till and dust frozen in ice. It's not a ton of salmon food, right? So there you have alders along the banks. Alders are what's called nitrogen fixating plants. So they put out nitrogen and other nutrients from their roots into the water. So in a case like that, where you don't have a lot of natural nutrient input, that's what's driving this whole ecosystem. The alders along the banks are what's putting in all the nutrients that feeds the plankton, that feeds the salmon, and the salmon feed everything else, right? So I like to use the analogy like the sun feeds the willows feed the moose feed us plus bears and wolves, right? Without the alders and the willows along the bank, some of these streams are just sterile. And so you have to have those root systems and those chemical processes along the bank to provide nutrients into the stream, to feed the plankton and so on. All right, so stream banks in shade cover. This should say vegetated stream banks in shade cover. So basically, all that vegetation leaning over the water provides a lot of shade from the sun and from predators. I'll kind of go through both here. So water temperature. Salmonids are lumped together as cold water species. So like the fisheries world, you kind of go, oh, it's a cold water species or a warm water species, which I always thought was kind of lame because like a northern pike is considered a warm water species, but they live all the way up in the Brooks Range. So it really doesn't make a whole lot of sense. But what it's really about is this second part. So the benefits of cold water are many, but the most important benefit is cold water's increased ability to retain dissolved oxygen. So as water warms up, it just can't hold as much dissolved oxygen in it. So like northern pike can live in extreme cold and extreme warm because they don't need as much oxygen as a juvenile coho or a rainbow trout or any of these other species that need a ton of dissolved oxygen in the water. And so, yeah, that part's fairly simple. If you, if we cut away all that vegetation and let all that sunlight in, there's not as much air in there for them to breathe. Warm water temperatures cause a rise in metabolism, stress, and susceptibility to disease, etc. So when you start thinking about this with salmon, a Chinook, let's go with a pink. So a pink has 18 months to get as big as they are, right? They don't live very long. From hatch to this, 6-ish pound fish, you got 18 months. So a rise in metabolism is a disaster for salmon because they have to eat constantly to put on all this weight in a tiny amount of time. So if you raise their metabolism, you're talking about making it harder for them to achieve that growth and ultimately lay eggs for the next generation, right? So getting a little into the weeds here, but there's a cool temperature units case study. So a lot of people know like bird eggs or mammalian gestation, right? If you put a chicken egg in an incubator, it's going to hatch in 21 days. If it goes 22 days, it's dead. If it hatches in 20 days, that just doesn't happen. So fish eggs don't work like that. So fish eggs, you can, how do you say it? Like, it's malleable, the amount of incubation time. So if you warm them up, they'll hatch sooner. If you cool them down, they'll hatch slower. The problem with doing that is that it makes them less healthy. They need to hatch in like a pretty narrow window, right? I want to say it's around 120 days. So if you heat them up, they'll hatch sooner but be underdeveloped and have birth defects and not be as healthy. If you cool them down, they'll use up too much of their yolk sac and won't be very fit fry when they're starting to emerge from the ground. So changing the temperature of a stream has far-reaching consequences for all parts of the salmon life cycle. So this one's kind of a fun one. I don't have anything against mergansers, but we've all seen these. You spend a lot of time on the Kenai, especially in the wintertime. These guys are everywhere. It's because we have a lot of salmon. I couldn't find any comprehensive case studies on the effects of streambank cover and salmon predation, but there are a lot of published studies on animal predation on juvenile salmon. So on the Big Qualicum River, I think I'm pronouncing that right, in British Columbia, I don't know how many merganser broods they tracked, but a series of merganser broods consumed 80,000 to 130,000 juvenile salmon over a 3-month period, over a summer. And a 1993 study on the Kadashan River in Alaska found that a family group of 4 river otters, just 4, that's probably a female and her 3 pups, ate 3,300 juvenile coho salmon and Dolly Barton over a 6-week period. So again, nothing against otters and mergansers, but these are all visual predators, and if you take away all the cover along the banks and just rip-rap out the banks, there's nowhere for them to go. They can't get away from them. And so you need to have those nooks and crannies and large woody debris in the water and other things for them to hide.
The state parks in the past, when you got a big cottonwood tree or spruce tree leaning over, starting to go out from the bank, we asked them to cable it off and cut it and keep the roots in the bank, and they wouldn't do it. And so I don't know if that's a feasible option and a usable option for a stream bank cover.
Sure.
But if you could work with state parks on something like that, particularly just downstream from where you guys are going to work, there's a little bit of an outcrop in there, and those trees tend to be going pretty regular from all this excavation from the
Sure.
ice.
Yeah.
And so that might be something to think about when you guys are working in that area too.
Yeah.
What time is it quit?
When we're done.
I'll be done too.
All right. So kind of get the next section here, stream bank and habitat diversity. So the big takeaway you have to have from this section is that there isn't like a ideal stream for all 5 species, plus steelhead, plus dollies, etc. No 2 species of salmonid in the rearing stage have the exact same habitat requirements. You have some overlap, sure, but you can't just make one stream fits all kind of scenario. It just doesn't work like that.